Hi and Assalamualaikum everyone. So today I would like to present our paper for Ethic 2022 with the title A Grey Oyster Mushroom Grading System Towards Malaysia Standard for Industrial Application Use. So before we begin our presentation, basically I would like to list the contents for my presentation today. So the first of all, I would like to introduce the basic idea about the grey oyster mushroom. Secondly, we will talk about the several problems that has been occur in this agriculture's issues related to grey oyster mushroom, and we will talk a bit about objective, and then later on we will talk about the most common and related works which related to the grey oyster mushroom. And then we will discuss about our methodology for the proposed project in this paper, and later on we will discuss about the result, and I will show the results and prototype results for this project, and finally we will conclude it. So I will introduce about the background of grey oyster mushroom. So basically, grey oyster mushroom is widely cultivated and consumed as supplementary food in Malaysia. So to ensure that the quality and grade for the grey oyster mushroom, which has a good quality at par of the demand from the user, so basically the grading system is crucial and essential for this particular point of view. So at the same time, in Malaysia, basically the Federal Agriculture Marketing Authority, alias FAMA, is published a standard for the grey oyster mushroom itself, which has been known as MS 2015-2012. So in this particular Malaysian standard documentation, basically we will have three categories of mushroom, whereby the first one is the best quality of the grey oyster mushroom. So second one is the quality that has that to be ready for the market, and the thirdly is the quality that is not in demand for the market. Okay, right. So what we have here is grade number 1, 2 and 3. So normally the grey oyster mushroom is categorized by its size, color, pattern and damage condition from the images itself. So speaking of the problems, basically we facing several problems in the site on-site or outside of the field. So the first thing first is the manual eye observation during the classification processes. Basically it was conducted traditionally by the eye observation, which apply the miscategory and less performance of grading, like grade 1. It could be divided as it could be classed as grade 2 and so on. So the majority of the grey mushroom related research work are conducted with interclass task. So interclass meaning that normally the research has been done so far is basically happen in multi types of mushroom. It's not dedicated to only one type of mushroom, whereby here the intra-class meaning within the grey oyster mushroom itself, for the study we still consider to have a difficulty to find the related works. So that's the reason why we stated here over here is the still limited and need attention for researchers in Malaysia. So we set our objective in this paper to be two. So first is to model a simple grading system for grey oyster mushroom, which is suited to Malaysia standard and agriculture industry. So whereby we will use the hardware via Raspberry Pi. So and then we try to develop the grading system via classification tasks, which utilizing the deep learning brain for categorizing the grey oyster with the help of graphical user interface for the inspector in order to classify them. So speaking of the rated work, basically we can say the 5 year trend of study happened in the mushroom. Rated work is from 2018, so up to recent year. So we can see over here the majority of them started to start classify the mushroom by using the machine learning and deep learning. We can see over here, and the trend for this study was multiple and could be single in sometimes. So single is done by Wong over here, doing this kind of mushroom. So but the single work for the mushroom is less rather than compared to the multiple. So speaking about our methodology for this proposed paper, so we divided in 2 phases for our work. So first phase is survey and literature, and the second phase is hardware and software construction. So first thing first is we try to discuss and analyze the demand from the FAMA itself, and we did the literature review, and we tried to find the compatibility and suitability study of software and packages that happen in the mushroom field. So in the second phase, basically this is the real kind of things happen in this paper, because in order to design the hardware and design to the hardware. So first of all, I would like to talk about the hardware setting. So over here we have a box which has been set with a webcam over here on the top of the box, connected to the Raspberry Pi at the back of this monitor, and this is the stylus which will be used by the inspector itself to choose to touch the display. So secondly, about the software setting, basically we will utilize the VGG16 over here. This will be this construction of VGG from the images itself to the layers that we have internally in VGG16. So here, whereby we do some additional contribution to the work for mushroom classification. We set the value of 0.7 in order to categorize them into 2 categories: can be sold and cannot be sold. So for the experiment that we conducted in through this paper, so we divided into 2. So first one is in-lab analysis classification task by having the matching accuracy. So over here we just focus on the orange line over here. So by far the average of this particular classification accuracy started from epoch number 4. We have approximate 94 to 95% accurate. So we can say that can be sold and cannot be sold categories are far enough and reliable to consolidate the result of, or to classify the result by a given image of mushroom. So this is the real case, whereby we put the mushroom in the box, in the box of in the figure that I showed before. So after we put inside the box, so basically the user interface of this in this monitor will display can be sold. So meaning this particular mushroom is basically classified or categorized by the first group, can be sold. Okay. So and then I will conclude my presentation. So basically from this research we can have the 94% of classification accuracy for the grading gray oyster mushroom, and basically we are trying to be close to the FAMA standard as we discussed before, MS 2015-2012. So basically we try our best to go as close as we can to the FAMA standards. But for the future work, basically since the FAMA standard have 3 classes in the documentation, basically we will add one more class, whereby the class was the grade A class, grade 1, okay, to be added in our future work. So we also looking forward to a research which involve another class rather than the same intra classes images. So whereby we try to add, instead of 3 classes, grade 1, grade 2 and grade 3, so we have 4. So the 4th one meaning other class. So that would be will be deliver a complexity and reliability of the grading system for long-term use for industrial production line. Okay, so with that, thank you for your attention.